Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 7 Linear Programming, Long Question Example 2. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A factory produces two types of ping pong bats, A and B. In a day, the factory produces X units of type A bats and Y units of type B bats. The factory uses two machines P and Q to manufacture the bats. Machine P needs 50 minutes and 20 minutes to produce a type A bat and a type B bat respectively. Machine Q needs 40 minutes and 20 minutes to produce a type A bat and a type B bat respectively. The production of bats by the factory in a day is subjected to the following constraints. So let me read all the three constraints. Okay, for the first one, the total time of usage of machine P cannot be more than 600 minutes. For the constraint 2, the total time of usage of machine Q has to be at least 400 minutes. For the constraint 3, the number of type A bats produced cannot be more than 2 times the number of type B bats produced. Okay, so let me read the question part A now. Write 3 inequalities apart from x more than equal to 0 and y more than equal to 0 which satisfy the above constraints. Okay, proceed to read the question part B. Using a scale of 2 cm to 2 units on the x-axis and 2 cm to 5 units on the y-axis, draw the graphs of the 3 inequalities. Hence, construct and shade the feasible region R that satisfy the above constraints. Okay, so from here, let us continue to read the question part C. Okay, based on your graph, answer the following questions. Okay, within question part C, you have 3 sub parts. Okay, let me read the part 1 first. Find the maximum number of type A bats that can be produced by the factory in a day. For the question C, part 2, find the minimum number of type B bats that can be produced by the factory in a day. Okay, for the question C, part 3, the profits from the sales of a type A bat and a type B bat are 4 ringgit and 6 ringgit respectively. Find the maximum profit that can be obtained in a day if the number of type B bats produced in a day is 3 times the number of type A bats produced. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us begin our discussion for the question part A, where we require to find the equations of the constraints available here. Okay, but before that, we need to gather the informations from this long statement over here. Let me guide you from there. So from here, as you can see, it mentions here x units of type A bats and y units of type B bats. So from this statement, you can come up with 2 important information where x is actually representing ping pong for bats A. So ping pong bats A, and y is representing ping pong bats B. Okay, so from here it also mentioned that the factory uses 2 machines, machine P and Q. So from here, let us write it down by begin with the machine P. So from here, machine P okay. So for machine P, it requires 50 minutes and 20 minutes to produce a type A bat and type B bat. Okay, so from here you can just write here A is equals to 50 minutes, okay, and B will be equals to 20 minutes. So from here, let us proceed to the machine Q. For the machine Q, okay, it needs 40 minutes and 20 minutes to produce a type A batch and type B batch respectively. So from here, your A will be equals to 40 minutes. So just write here 40 minutes. Okay, and your B will be equals to 20 minutes. Okay, so these are the requirement. So as you can see here, we have already converted these long statements into equation over here. Now it's better for us to read. It is easy for us to understand as well. Okay, so within this information, we're going to come up with the 3 constraints over here. So let's find them one by one. So by begin with the constraint 1. Okay, so constraint 1 mentioned that the total time of usage of machine P cannot be more than 600 minutes. Okay, it mentioned here machine P. Okay, so for machine P, so this is your machine P, right? So you just include them. So from here, since A is representing X and B is representing Y, so from here your equation will be 50X plus with 20Y. Okay, it mentioned that cannot be more than 600 minutes. Okay, so from here your maximum value that you can obtain from here is 600. So it should be less than equal to 600. Okay, so from here you can simplify this equation by divide the whole equation by 10. So from here you get 5x plus 2y should be less than equals to 60. So this is your first constraint. So let me underline this. Okay, so from here let us proceed to the constraint 2. Okay, constraint 2 here mentioned that the total time of usage of machine Q has to be at least 400 minutes. Okay, so take a look at the machine Q over here. So this is the machine Q. Okay, so from here what you need to do, since A is representing X and B is representing Y, so you just include them all together. So from here 40x plus with 20y. Okay, take a look at the keyword here. It mentioned that at least 400 minutes. So the minimum value that you can have is the 400 over here. So it should be more than equals to 400. Okay, so to simplify this equation, so you divide the whole equation by 20. So from here you should get 2x plus y should be more than equals to 20. Okay, so this is your second constraint. So let me underline this. From here, let us proceed to constraint 3. Okay, constraint 3 mentioned that the number of type A batches produced cannot be more than 2 times the number of type B batches produced. Okay, so type A batch is X, so just write here X. Okay, it mentioned here cannot be more than 2 times. Okay, cannot be more than means it should be less than equal to. So from here X should be less than equals to 2 times the number of type B. So 2 times type B, so it will be 2y. Okay, since your type B is Y, so it will be X less than equals to 2y. Okay, but since we are required to plot the graph in our upcoming working, so we are required to shift this order. So from here your y should be the left hand side, and your x should be in the your right hand side. So from here you shift this order. So from here it will become 2y more than equals to x. Okay, so to find your y, it will be to be more than equals to 1 over 2 x. Okay, so this is your third constraint. So let me underline the third constraint. Okay, so from here let us proceed our discussion for the question part B. For the question part B, we are required to draw the graph of the three inequalities that we have found in the question part A, and we need to construct and shade the feasible region R that satisfy the above constraints. Okay, by the way, I've already completed the graph and shade the region for you. So let me show you the complete graph now. Okay, so please wait. Okay, so this is the complete graph. So as you can see here, this is the linear programming of the ping pong bats. If you can't see it clearly, so let me zoom in for you. Okay, I hope this is clear enough. So as you can see here, this is the title of the graph, linear programming of ping pong bats. Okay, and as you can see here, this is the graph of the first constraint, where 5x plus 2y is equals to 60. Okay, and then proceed with the second constraint. Okay, 2x plus y is equals to 20. So this is your second graph. Okay, and then your third graph is y is equals to 1 over 2x. Okay, and this is how your graph should looks like. Okay, let me zoom out a bit. Okay, so to plot the graph, you choose any 2 points, or you can choose 2 intercept, x and y intercept, and from there you can able to plot the graph, guys. It's very easy. Okay, so once you plot the graph, then you need to require to find the region of the inequalities. Okay, so for that, so let me open this, okay, and show you one by one. So please wait. Okay, so let us begin with the constraint 1. So since the constraint 1, it mentioned that 5x plus 2y should be less than equals to 60. Okay, less means it should be downward region. Okay, downward region means, okay, so you should be marking over here. Okay, mark every possible region, guys. So you can mark here. Okay, and then mark here. Okay, then mark here and mark here. Okay, you can still mark here because 5x plus 2y equals to 60, still within the range, guys. Okay, this is a bigger range, so it is possible to mark over here. Okay, so that is for the first constraint. For the second constraint, 2x plus y should be more than equals to 20. Okay, so from here, since it should be more than equal to 20, so you mark over here. Okay, you mark here, you mark here, you mark here, and you mark here. Okay, so 2x plus y more than equals to 20, so indicating that your region is upward, the graph. Okay, so and then let us proceed to the third constraint. Okay, your third constraint mentioned here, y should be more than equals to 1 over 2x. Okay, so since it is more than equals to 1 over 2x, so this is the possible region, so you mark here. So you mark here. Okay, you mark here, and you mark here. Okay, mark here, and you mark here. Okay, so can you see that this portion has the most numbers of colors over here? I mean the fulfilling the inequalities. So that is the reason why I shade throughout this whole region, guys. Okay, so I hope you understand the concept which I'm trying to tell you. Okay, so let me erase this. Okay, so that is how I get this polygon region, and don't forget to mark a R over here. Okay, write a region R over here. So that is the important thing. Okay, so that is all for my explanation for the question part B. So from here, let us proceed our discussion for the question part C. So let me close this graph and open the question. Okay, so from here, for the question part C, okay, let us begin our discussion for the question C part 1. Okay, it mentioned here, find the maximum number of type A batch that can be produced by the factory in a day. So this requirement we need to find based on the region that we shade, guys. Okay, let me be clear with you. So let me open the graph paper again. Okay, so as you can see here, this is the region, and we need to find the maximum x value. Okay, the possible maximum x value. So as you can see here, this is your possible x maximum. Okay, so let me circle over here, let me mark here. Okay, so this is your possible x value. Okay, so from here you got it clear. So your x value is 10. So back to our discussion. So let me write in the working here. So question C part 1. So from the graph, so we find out that our x maximum is equals to 10. Okay, it's very straightforward. So we just underline this. Okay, so from here, let us proceed our discussion for the question C part 2. Okay, for the question C part 2, we need to find the minimum number of type B batch. Okay, type B batch means indicating we need to find the minimum value of Y that can be produced by the factory in a day. So let me open the graph paper again. Okay, in this case, type B batch means Y. So we need to find the possible minimum value of Y. Okay, so you need to look the vertical height here. So this is the minimum value of Y. Okay, if you can see closely, it's actually 4. But if you can't see it clearly, so let me open the another image. Okay, and I zoom in. Okay, so if you can see it clearly, it's actually representing 4, guys. Okay, 4, and then once you surpass the 2 small box, you'll get here 5. It intersecting directly over here. So you should mark your region over here. Okay, so when you mark it here and you plot it at the y axis, so you can see it gives you your y minimum equals to 4. Okay, so let me zoom out this and mark it over here. So from here you get your y minimum is equals to 4. Okay, so let me erase this and back to our main discussion. So from the graph, okay, so you get your y minimum is equals to 4. Okay, so let me underline the solution. Okay, let us proceed our discussion for the question part 3. Okay, question C part 3. But before that, okay, let me just open the graph paper for a moment. Okay, you might be wondering why there's suddenly a dotted line of y equals to 3x and a max point of 515. Okay, is a reason, guys, okay, that we're going to discuss in our question C part 3 now. Okay, so why we come up with this dotted line and this maximum point. Okay, so please hold on for a moment. I will come back to that soon. Okay, so for now, let me close this and proceed to the question C part 3. Okay, so it mentioned that the profits from the sales of type A bat and type B bat are 4 ringgit and 6 ringgit respectively. So we need to come up with the profit equation. So based on this statement, we can come up with our profit equation where P is equals to, okay, type A bat is actually X. So from here, 4 you times with X. Okay, so 4X. Okay, and then you plus with 6Y. Okay, 6 ringgit you times with the type B bats. Okay, type B is in this case is Y. Okay, so 4X plus with 6Y. Okay, so from here, so let me box this profit equation. Okay, and then continue to read the question. They mentioned that find the maximum profit that can be obtained in a day if the number of type B bats produced in a day is 3 times the number of type A bats produced. So can you see the reason why we have the Y equals to 3X? So based on this equation, based on this statement. Okay, so from here, type B bats in this case is Y. Okay, 3 times the number of type A bats produced. So it will be equals to Y equals to 3X. Okay, so from here, if Y is equals to 3X, okay, so we are required to plot this graph. So let me open the graph paper again. Okay, by the way, I've already plotted the graph for you, the Y equals to 3X. So you can choose any 2 points. Okay, so from here, you choose any 2 points and then you plot the graph of Y equals to 3X. Okay, so easy as that. So once you plot the graph, so from there you need to find the maximum point. Okay, so this is considered like your new constraint, guys. This Y equals to 3X. So from there, you can find that your maximum point is actually representing 5, 15. Okay, so let me zoom in for you and show it to you clearly why it is 5, 15. So this is your x-axis, which is the 5 of bats A and 15 of bats B. Okay, if you can wish to move further, yes, you can move further, but if you end up by moving further, you will end up by getting a decimal value of bats. Okay, which in reality it is impossible to have bat in decimal number. You should have a number of number of bats in whole number itself. Okay, like a real whole number, for example like 5, 8, 12, something like that. You cannot have a decimal value. So this is the only possible maximum point that we can obtain based on this Y equals to 3X condition. So from here we get our max point is 5, 15. So this is the reason, guys. Okay, so we get our max point. So from here, so what we need to do is we need to use this max point to calculate our maximum profit. Okay, so we're going to use this information to calculate our maximum profit now. So from here, back to our main discussion. So from here, so from the graph, okay, so we find that our max point is equals to 5, 15. So thus our maximum profit will be equals to 4 times with 5 and then plus with 6 times with 15. Okay, you substitute this value into this equation respectively. So from here you get your maximum profit is equals to 110 ringgit. Okay, so this is your final answer. So let me underline the solution for the question C part 3. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.